I'll be presenting this busy diagram about types of performance testing, one concept at a time. The work of performance testing is about imposing different levels of load over a period of time. The intensity of load imposed is defined by the number of virtual users that load generators inject. The outcome from load testing experiments is the rate of processing, stated in hits per second or per minute, which the server can sustain, a metric that can be monitored in production. Finding that rate is one of our major objectives because we want to provide actionable intelligence to operations in production. The first thing, even while the application is being built, is a way to return a service unavailable page if the application doesn't respond to browsers pointing at it. It's useful to have an availability check on the server running around the clock at perhaps an infrequent one request every 10 minutes. That's 6 per hour or 144 hits per day. This is so that if it's down, you'll get an email, because that affects employee and customer productivity and satisfaction. Many such services are offered free. We begin by identifying the quickest rate users can optimally ramp up. We need to know the maximum number of users who can really jump on a system at about the same time. This is so we can predict what will happen at the beginning of a call center shift or some other peak time. The rate new users enter the system can cause a bottleneck as well as a high number of concurrent users running, because limitations in the authentication infrastructure is often a bottleneck. The scenario that keeps adding more and more new users is called a stress test. If we start with a very aggressive rate, where we see error messages, we've made some progress because every set of machines has some bottlenecks, and our job is to find them. When we identify a particular rate that is too quick, we ask if it's the memory, CPU cycles, or network. Such information is the heads up that operations people need to know. We usually need to try different rates to bring up the most number of users the quickest. Stress test scenarios are used in failover tests run to ensure that users can indeed be diverted to another availability zone or region for disaster recovery. The point we want to find is not the server's breaking point, but right before user experience degradation occurring, when response time begins to suffer due to load. That is the true capacity of the system under test. From that capacity level, we add lead time to calculate the threshold when we request additional capacity. If we have on-premises machines, the lead time can be like 6 months. That is why companies working with a fixed capacity would overbuy to get headroom to absorb future growth that may not come. The value of an elastic cloud such as Amazon and Azure is that we pay only what we use when we use it. Doing load testing helps us be more precise than just guessing at a CPU percentage as the threshold for bringing on another machine. The less headroom we allow, the more usage we can get out of machines we pay for. We calculate headroom based on the nominal actual level of load, the momentary peaks reached during each day, the level where long soak tests are run to ensure the endurance of the system over time, to ensure that the level is sustainable without memory leaks and excessive use of disk space. The nominal rate is also what we use in the flat portion of smoke tests after ramp-up. Such runs sustain the nominal load for a short period of time, such as 10 minutes, to prove the viability of an environment built after configuration changes. We do spike tests to verify resiliency, the ability of the system to absorb sudden temporary spikes in load while maintaining adequate response time. The system should then return to previous levels of memory usage when back at the nominal rate of operation. If we operate a cluster of servers, we need to make sure we have the elasticity we hope for. In an elastic cloud environment, we need to ensure that our configurations can indeed instantiate additional capacity on a timely basis. Tests of elasticity should also include uninstantiation tests to make sure that instances are indeed reduced when load recedes below the threshold limits,